On the 18th day of Advent of Cyber, TryHackMe gave to me an obfuscation file filled with mystery. Hello everyone, my name is Alisa and welcome to my channel Tech Alisa, and welcome to day 18 of TryHackMe's Advent of Cyber. Congratulations for making it to day 18! I am super proud of you and you should be proud too, so pat yourself on the backs. You have learned so much in the past days, in the past rooms, alongside amazing creators. And best of all, you might win some amazing prizes. This year, TryHackMe has prepared $150,000 worth of prizes. All of these prizes are so cool and incredible. It's like TryHackMe saw my wish list and said, let's put all of them to the prize draw. Don't forget that for each room you complete, you receive a raffle ticket. The more tickets you have, the higher the chance that you will win an amazing prize. Daily challenges for the Advent of Cyber will be released every day until 24th of December. But don't worry, if you've missed a day, you can still catch up on. You can play until 31st of December and still participate in the prize draw. I'm super excited to start day 18 with you, so let's learn some obfuscation.
Once again, welcome to day 18. This room is called Obfuscation, the egg shell file. We continue our story from the previous days. Wareview hasn't been the same since the wormhole appeared. Everyone in the best festival company is on high alert. Systems are going out of control, dashboards are spiking, and SOC alerts have been firing non-stop. Amid the chaos, MaxKitty finds a particularly interesting alert. An email posing as North Pole HR. It is littered with carrot emojis, but the weird thing is, there is no North Pole Human Resources Department. The best festival company's HR is at the South Pole. Plot twist! MaxKitty digs further and she finds that the email has downloaded a tiny PowerShell file. Suspicious. Among the code are random strings of characters which are all gibberish. Nothing can be readable at a glance. MaxKitty knows malicious actors often hide code and data using a technique called obfuscation. What is obfuscation? What is encryption, decryption, and coding? Are they different? Are they the same? And what is CyberChef? Today we're going to learn this together. We see that for this room we need to start a virtual machine and it is available in split screen. We don't need to do anything else, we just need to click on the start machine. It will take a few minutes to load. Now, if you prefer to connect directly to the virtual machine using your old computer, you can use the credentials as shown below. If you have zero idea what RDP is or how to connect, don't worry, TryHackMe has provided you with this virtual machine with which you can do the whole room. We can now click on check and we officially have the first correct answer and we have progressed in the room with 25%. Amazing! Before we do the practical tasks and find the flags, we're going to go over the theory in this room in order to better understand how to find the flags. What is obfuscation? Obfuscation is the practice of making data such as code and text difficult to read and analyze. Attackers use it to evade basic detections and slow down the investigation of incident responders. Let's say that a security tool will automatically block any file that contains the word "the bandit Yeti." How can an attacker evade this? Well, the attacker can use a simple cipher technique called ROT1 to hide the string. Cipher techniques are like recipes for scrambling and unscrambling messages. In simpler words, they take normal text, then they scramble it using rules or keys, and this turns into unreadable message. To get the original message back, you need to know what rules and keys were applied in order to reverse those. Some examples of cipher techniques include substitutions, which is replacing letters with other letters. Today we're going to look at ROT1 and ROT13. Another example is transposition, which rearranges letters. We can also have XOR-based encryption, which is something we're going to look over today as well. And we also have a lot of algorithms which can encrypt and decrypt messages. Let's look at route 1 cipher technique. This technique shifts each letter forward by 1 in the alphabet. Let's look at the picture, for example. We have the word carrot. So when we use route 1 cipher, it moves each letter forward by 1. So, for example, we can see here that we have C, and if we move one letter forward C, we have D. For A, if we move it one letter forward, we have B. For R, we have S, and for O, one letter forward is P. And for S, one letter forward is T. So initially we had carrot. When we applied the route 1 cipher technique, we get this scrambled message DBSSPU, which means nothing. But if you know that this is route 1 cipher, you can apply it in reverse. So we go backwards by one letter in the alphabet. So D becomes C, B becomes A, S becomes R, P becomes O, T becomes S, and we get the original message carrot. We can do the same thing with route 13, which moves the characters forward by 13 spaces. Now route 1 and route 13 are very simple ciphers. In the real world, attackers use more complex ciphers, of course, so that you cannot be able to very quickly decipher the message. More complicated techniques would be utilizing XOR. In order to use XOR, each character is represented as a byte, and each byte is combined with a key using the XOR mathematical operation. It is also important to note that this operation changes the bytes into different bytes, which sometimes make the resulting text end up with uncommon symbols or non-readable characters. Now for this room, you don't need to know how XOR exactly works, but if you're curious and want to learn more, of course research how XOR works and its inner workings. But right now I'm going to show you a very easy and free tool you can use in order to encrypt and decrypt ciphers such as XOR. The tool is called CyberChef. You can open it by visiting the provided link, and what you see is the following interface. As I mentioned previously, cipher techniques are like recipes for scrambling and unscrambling messages. So here we can create a recipe for encoding or decoding a message. You can put your message in the input, the recipe is applied to the input, and that gives you the output. Let's try, for example, what we've learned so far, which is route 1. Now there's no route 1 in the options here, but we can use route 13 and actually change the amount to 1. So let's do carrot. And we can see DBSSPU, which is absolutely the same thing that we saw as in the example. As you can see, we already have the input because we have clicked on Auto Bake. If you don't want automatically to receive the output, then you can, for example, let's change the input to carrots, and then let's click on Bake, and we already have a change. I like to use Auto Bake because sometimes I forget to click the bake and I wonder why the output doesn't show up. Now let's, for example, take this longer message, carrots coins go brr, and see what happens when we input this. Route 1 is applied to our input and we get this output, which is exactly as shown here. Now let's try with route 13. We can just change the amount to 13 letters forward and we get this output. Very easy, right? It does everything for you. You don't have to think at all. Now let's clear our input, let's clear also our recipe and explore what we have. In favorites, we have the most used ones. If you hover above any of the blue rectangles, you get explanation of what this is and what it does. There's also a lot of encryption and encoding cipher techniques you can try and play around after this day. You can do so many different things. I encourage you to play around with CyberChef after you finish this room. Now let's see how XOR works. Search for XOR in the search bar and put the recipe on our recipe. We are asked for a key. We can pick different keys and we can pick different schemes. Let's see what TryHackMe has said. The input given is carrot supremacy, and because we haven't put a key yet, the output stays the same. We need a key in order to encrypt with XOR, and we need to know the key in order to decrypt the XOR. We need to set the key to A and to hex. So we set to A and we get the following XOR output. Congrats, we have encrypted our first message with XOR. This red dot indicates that we have a space. So the normal numbers that we use every day, 0, 1, 2, 3, 4, and so on, are called decimal numbers. Then we have binary numbers, which are 0 and 1. This is the language that the computer uses internally. In case you're wondering what hex means, this means hexadecimal. These are numbers from 0 to 9, as well as letters from A to F. This is a compact and easy way that the human can read binary. How can we decrypt a message that used a well-known obfuscation technique? So sometimes it's not that difficult if we know what the obfuscation technique used was. Then we can reverse it and decrypt the message. And a simple way to do this is to detect patterns. Let's take row 1 for example. We know that with row 1 we move the letters forward by 1, so it is very easy to detect because we know that words have their letters one letter off. For row 13 we should look at 3-letter words. Search for common words like the, which becomes gur, and also search for and, which becomes NAQ. Base 64 is also quite easy to spot because the strings contain mostly alphanumerical characters, sometimes with plus or a forward-leaning slash, and often ending in one equal sign or double equal signs. Let's see in CyberChef how this looks like. I'm going to keep the same input, but I'm going to clear the recipe and search for base 64. Now I want to make my input into base 64, so I'm going to say to base 64. And as you can see, the double equal signs in the end indicate that this is base 64. XOR is a bit more tricky to detect patterns in. The XORed string looks like random symbols, but it is important to note that it stays the same length as the original string. If a short secret was reused, you may notice a tiny repeat every few characters. Sometimes you might not be able to identify a pattern, so you might not know what the cipher technique used was. In such cases, CyberChef can be of great help. It offers an operation which you can find in favorites called magic. Now, in order to test how magic works, I'm going to take this base 64 output, I'm going to copy it and paste it as my input. I'm going to remove this recipe and I'm going to put the operation magic as my recipe. Did you see what happened here? Here CyberChef gives you a list of recipes and result snippets that it thinks the input might be in. We already know that this is base 64, but we can also click it to put it as a recipe and we get our output. Magic also has an intensive mode which tries for more possibilities and gives you more results. Magic is a very useful first step to do when you don't know what the cipher technique used is. However, it is not able to catch everything, especially if you use a custom key or layered encryption. Layered encryption or obfuscation is something that threat actors do to make the obfuscation harder. They combine multiple cipher techniques and thus create a layered approach. Let's take this example. We are told that the threat actor has done 3 things on the script in order to hide it. First, the threat actor has compressed it by using gzip. Gzip is a compression format used to shrink files to make them smaller. Then the threat actor has XORed this compressed script with an X key, and then in the end he has applied base 64 encoding. In the end, we get this obfuscated string. Let's copy it and try to reverse it with CyberChef. Because we're given the 3 steps of layered obfuscation, we know how to reverse it. We take the same steps but in reverse order. So we start with base 64 decoding. We know that the threat actor has XORed with X, so we search for XOR. We put X as the key. And then in the end we know that the script has been compressed with gzip. Now in order to decompress a gzip compressed file, we have to use gunzip. Now we have our recipe, our 3 steps in reverse, we have the input and we can see that the output has already been baked. We can see the PowerShell script that the threat actor has obfuscated initially, and we can see that it lists the current folder in a simple table. And we can see the code as well. I hope this theory and the examples were clear to you. If you have any questions, please let me know in the comments and I'll try to answer all of them. Now we have reached the practical tasks. Unwrapping the Easter egg. As we read in the beginning, Max Kitty detected something fishy in the email that the Best Festival company received. She managed to extract a PowerShell script from the PDF and put it on an isolated virtual machine to figure out what was going on. We use an isolated virtual machine in order to safely analyze the malicious code without infecting our own system, our own computer, our own laptop. This is called sandboxing. The malicious code won't be able to escape the isolated virtual machine and infect your own personal laptop. Now let's see what the task is. I'm going to click no on this and let's see. Open santastealer.ps1 located on the virtual machine desktop and scroll down to the Start Here section of the script. Follow the instructions in the code's comments and then run the script from a PowerShell terminal to get your first flag. To open PowerShell, click Start or press the window key, type PowerShell and press Enter. In the PowerShell terminal, run the 2 commands shown in the script's comments. Time for hacking. Let's first open santastealer.ps1. I'm going to double click on it and wait for it to load. And it opens in Visual Studio Code. Visual Studio Code is a lightweight coding editor used to read, write and debug scripts and programs. We are going to use Visual Studio Code today to modify the code. I want to see the code in a bigger screen, so I'm going to use the View in Full Screen feature. I'm going to click on it and it opens a new tab which displays the virtual machine in full screen. Now, if you're curious about what the code does, you can of course take some time and read it. It might not be easy to understand if you're a complete beginner, so don't worry, you don't need to know what the code actually does in order to finish this room. But I can tell you that what the code does is establish a C2 connection. C2 means command and control connection when malware contacts its attacker server to receive instructions or send stolen data. It's like a remote control center for the attacker. We can see here that when the attacker connects, he'll be able to collect the host and the user context, as well as to steal Santa's presents list. But once again, you don't need to know any of this code, you just need to focus on part 1 and part 2 in order to get the 2 flags. I can see that part 1 deals with deobfuscation. We need to deobfuscate the string present in the C2b64 variable and place the URL in the C2 variable. Then we have to run this script in order to get the first flag. So we need to take the string in variable C2b64, which is this string. We have to copy it and then we're going to use CyberChef in order to decode it. Let me clean my recipe, let me clean my input. I'm going to put the string I just copied into my input. And now the thing is, I don't know what Cipher technique was used for this string. Do you remember how we deal with this? We go to favorites and we use the magic operation. It will give us immediately some guesses. You can see in the results that it's from base 64. I'm going to click it and then I get this output. I'm going to copy the output and I'm going to paste it here. This is our C2 URL here. This is the remote command and control URL that the attacker used in order to connect. Now I'm going to save this file and I am going to go back to the split screen in order to see what I have to do next. Next we have to run the script from a PowerShell terminal. So I'm going to click on the magnifying glass here and I'm going to type PowerShell. I'm going to click on it and it opens a Windows PowerShell terminal. We have to change the directory to desktop, so we use CD and we are in the desktop directory. Then we have to run the script using the following command. And now I press enter and we see what happens. Ooh, we get some comments. Something is happening. The C2 connection is establishing. And we also get our first flag. Congrats! Let's put it here. Yay! Ah, the feeling is amazing. When you find a flag, it's amazing. Alright, we have one more flag to find out. Let's go back to our code. I'm again going to view it in full screen. And we scroll to part 2, obfuscation. Obfuscate the API key using XOR single byte key 0x37 and convert to hexadecimal. Then add the hex string to the obfuscateey variable. Then run the script again to receive flag number 2 from the validator. So we have to take the following API key, obfuscate it with CyberChef and put it here. I'm going to copy this. I'm going to clean my recipes, clean my input, and I'm going to paste my API key. We are told that it uses XOR single byte key 0x37. So we search for XOR, and we are told that the key is 0x37. This is just a number written in hexadecimal in base 16. In decimal numbers, this equals to 55. Again, there's no need to know this for this room, but now you learned something new, and we are all about learning here. Now we have the following output for XOR with key 0x37, and we are also told that we have to convert this to hexadecimal. So we search for hex. To hex converts the input string to hexadecimal. Copy this output, and we have to put it inside this. We save this file now, and then we go back to our Windows PowerShell in order to run the program again. If you click on the upper arrow of your keyboard, it will show you the previous command, which is exactly what we need. So I press enter and we see what happens. And we get the second flag. So exciting. So let's put it so we get the confetti in the end. And check. If you want to learn more about obfuscation, there is a room specifically about obfuscation principles. For now, I'm just going to press on check so I can get the confetti. Amazing!
Congratulations, you completed day 18. I am super proud of you, and you should be proud too. Don't forget to share your success on social media and tag me as well, because I love to cheer you on and I love to root for you. If you have any questions about day 18, the material, or Advent of Cyber, let me know in the comments below and I'll answer you. Subscribe to my channel because I have a lot of good content about cybersecurity and AI coming up, especially in 2026. I wish you lots of luck in the next days of Advent of Cyber, and good luck for winning one of the prizes. Let me know if you do. Happy hacking, and I'll see you in the next video.